All right, last two here, 17 and 18. On number 17, appears we have a fraction plus a fraction equals a number, and that number would be over 1. So we do have a fraction plus a fraction equaling a fraction here. And we would look to factor first, and it doesn't appear that x can factor or x plus 2 can factor, and that's just a 1. So everything's already factored. So now we're going to look for our least common denominator, which in this case we need a factor of x to cancel with an x. And to cancel with an x plus 2, you would need an x plus 2. So apparently here we have a similar common denominator. So that's what we're going to multiply through by in order to get rid of all of our fractions. And again, our goal here is to have no fractions left after our first step. If you have a fraction left after your first step, you have done something wrong. So we multiply our first fraction, and the x cancels with the x, which leaves you with a 15 and an x plus 2. In the second fraction, looks like the x plus 2 cancels with the x plus 2, which leaves you with an x and a 9x minus 7. And in the last term here, on the other side of the equal sign, it doesn't appear anything cancels here, so you're going to get a 9 times an x plus 2. So it looks like we have a lot of distributing to do. We have to distribute the 15, the x, and the 9x. So when you distribute the 15, you get 15x plus 30. Distribute the x, you get plus 9x squared minus 7x equals. Now we're going to distribute the 9x. 9x times x is 9x squared. 9x times 2 is 18x. And now something very nice happens. We have a 9x squared on this side and a 9x squared on this side. So if you were to subtract, they would cancel each other out. We should then combine up like terms here. The 15x and this negative 7x gets you positive 8x plus 30 equals. On this side, you're just left with 18x. Since the larger x value is on the right, I'm going to keep it on the right. I'm going to subtract the 8x over, so it's going to leave you with a 30 on this side. Subtract 8x from 18x, and you get 10x. Divide both sides by 10 to get x by itself, and x is equal to 3. Okay, we'll just need to check our domain. And on this one, for your domain, pairs a bad value of x there would be 0. Because if you plug 0 in for x, you get 0. You can't have 0 in the denominator. And on this one, it looks like the bad value of x would be negative 2. So those are your, that's the restrictions on your values of x. And apparently 3 is an acceptable value, so that's our final solution there. All right, in our last problem, here we have on number 18, 3 over x equals 4x plus 1. So we have a fraction on this side equaling, now there isn't a fraction over here, but since none of these terms are fractions, we could actually make this entire side into a fraction and put this whole side over 1, which would be quite nice because now we've turned this into a proportion. So that means we can just go ahead and cross multiply on this one. So 3 times 1 is 3, equaling x has to get multiplied by the 4x plus 1. So then here we can go ahead and distribute our x to both terms. So you get 3 equals x times 4x is 4x squared. X times 1 is x. Okay. Then here, apparently, since we still have an x squared here, we have ourselves a quadratic, which has not happened too often here. So on a quadratic from the last unit, we have to set this equal to 0. So 0 equals, we're going to have to subtract the 3 over to the other side. So you get 4x squared plus x minus the 3. So we're going to need to try to factor that. Hopefully that will factor. Okay. So for the first term, we could use 1 and 4 or 2 and 2, but thinking ahead here, since we're going to have a 3 here and a 4 there. We can get a 1 out of a 4 and a 3 if we just go ahead and subtract 4 and 3. And since we have a negative 3, there's a possibility we can do that. So let's go ahead and try to use 4x and x. And let's try to use 1 and 3 here, but let's not let the 3 multiply by the 4 because we don't want the 3 and 4 to get you 12. So I'm going to put the 3 here and the 1 here. This will get you 4x and this will get you 3x. Now, I'd like us to end up with a positive 1, so 4x times a positive 1 would get you positive 4x, and negative 3 times x would get you negative 3x, which would combine together to get you positive 1x. Okay, so then we can go ahead and get our solutions here. Either this or this has to equal 0, so 4x minus 3 could equal 0, which means 4x could equal 3. Or x could equal, dividing by 4, 3/4. And then for this term, obviously if x plus 1 equals 0, then x would equal negative 1. So these are our two possible solutions. We just need to check our restrictions on the original problem. So our domain here looks like the only value we have in the denominator is an x there, so the only thing you could plug in the x to get you 0 would be 0. So your domain, the only bad value would be 0. And since we had a 3/4 and a negative 1 as our solutions, those are both acceptable answers. Okay, so that concludes those problems for the review.